we'll start our class on the topic of curve fitting. So, what is curve fitting? So, curve fitting is usually used in engineering interpreting data. Okay, so as engineers, we are presented with data, or in our experiments, we gathered some data. Now, the question is, how do we interpret these data, or what is the relationship between the dependent and dependent variables? So the present topic deals with techniques to fit curves to certain data. Okay. In addition, you may require a simplified version of a complicated function, or in some area you want to determine or you want to get values intermediate, no, between two certain points which are not present on your table. So all those I have mentioned is part of what we call curve fitting. So our objective is to uh, determine the best fit. So for example, you have here 4 data points. Okay, so you have observed that as the value of a, or value of x increases, f of x also increases. So there is a relationship. So the question is, what is that relation? Is it increasing? Is it decreasing? So there are many ways to interpret this one. You can actually make a straight line, or you can connect these points. In other words, other methods, you can uh, fit a curve function. So the question now is, which of these three is the correct representation? So in order for us to determine that one, we'll use a method called the least squares regression. Okay, least square regression. So again, as I have mentioned, if you are presented with this data from your experiments, now different person will interpret it differently. No? You can either fit a curvilinear function, or you can fit straight line. So the method of least square regression will tell us which of these function is the correct representation. Review first some simple statistics that we'll be using for curve fitting. Okay, so first of this is the arithmetic mean. Okay, so sample, you have a 24 data points. Okay, this one. So this is a reading from determining the coefficient of thermal expansion for a structural steel. Okay, so the first statistical tool that we'll be using is the arithmetic mean. So it will give you the average, or the middle value of your data. Okay, so in definition, it is just, you just add all this data and then divided by the total number, and you will now get the arithmetic mean. So this will be the location of your center data. And if you want to get the spread or the how much is the data differ from the center point or the arithmetic mean, you have the standard deviation. So this standard deviation is defined as the square root of ST or the total sum of the squares of residuals. Okay? Or the difference from the data and the mean. Okay? Then you square that divided by the n minus 1. So you'll get the standard deviation. And also, we'll be using the variance, which is just the square of the standard deviation. Okay, so those are the basic uh, statistical uh, jargons that we'll be encountering in our curve fitting. And by the way, that is just a review. Okay, so your data points will actually look like this, a normal distribution. Okay, so this one, the data in the center value, this is the mean. Okay, this is the mean, and then uh, from the mean, you can actually get how much is the spread of your data from the arithmetic mean. Okay, we will demonstrate the method of least square regression. Okay, so this is the concept. Say for example, you have from your experiments, you have obtained this data. Okay, then this one. Okay, so how do we, our objective is to determine what we call the best fit or the curve that will best represent this data. Okay, what we'll do in the least square regression is pwede nimo ni you will do this graphically. Bato ni mana is you get a ruler. Okay, what you will do is you get a ruler and then kung mata-mataho no. Ah, ana siguro no. You're dili ka sure, you're not really sure. Pwede pud ana ang line. So may tabuan ni lahi nga tawo mo interpret, lahi pud og makuha nga graph. So dili ta na nga method no. We'll not use that method. We'll use the least square regression. Okay, so unsay concept ng least square regression? So ni reason na. Ang least square regression ani ang concept sa least square regression. This is x, this is y. Okay? Kung naa kay points dere, ampol ka ni. And then butang ka lang ana na kay points. So, ang buhaton sa least square regression is kay linya, kay line. Wala na. Kay line. Muning gitawag og regression line or best fit line, no? Anang line nga imong represent sa imong data. So posible ana na yung mga points nga dili mo magtunong, na apoy points na motunong, no? So ang mga points nga motunong ana karon, sample kani, wala man ni mitunong. Unsa na siya nga point, that is butang ta lang. This is x sub I. Kani y sub I. Okay? Now, sa regression nato, mo ni nga to ang kani nga point mo imo represent ani, no? So mahitabo karon kani nga part mo na ni error nato. Mo na error nato. So kani unsa man ni siya nga point kani. Butang ta lang kani nga equation, ang equation na y is equal to equation sa line AO plus A1x, no? AO plus A1x. So kani nga point karon, buhato na to, i-determine na to unsa ang value sa error. Kani nga point xi man, so ato i-substitute dire. So ang value anin is a sub o plus a1 xi. Okay? So what is e? What is error? Error is equal to kani, di ba? Difference ani. Y sub I minus kani AO plus A1 xi. Okay? So mao na siya. Mao nay error niya. Okay? So, or error is equal to y sub I minus AO minus A1 xi. Okay? So, method na to is least square regression. So, ang objective nato karon dapat gamay kay ni nga error, no? Gamay kay ng error para ma-represent jud niya sakto ang imo ang data sample kana. Kung dire kani nga line, siyempre dako kay error. So dapat ang best fit nga line dire gid siya. Ma-minimize niya ang error mo na objective. So para mo gamay pagid ni siya nga error, ato ning square. Kaya para, di ba? Ang error na 0.1 kung imo nang i-square sa may tabo, may mong 0.1 is 0.01. 0.01. O, nahimong 0.01. So, mas may gamay. No? So, mas mo gamay kung i-square na to. And then, by the way, naikulang. Ay, sa square. Pero, square na to later on. Ang total error ani dayon, total error kay daghan man kay nga point is the summation of errors. Okay? From 1 to n. Kung pila ka buok points nimo. And then kani summation po nato ni. Summation of y sub I minus ito na lang i-combine. Summation of kani isa man mo ni tanan. Okay, muna ang error nato. Muna total error nato. And then buhaton nato to ning a square nato. Para mo gamay pa jud ang error. So may tabuan ni ay madali siya summation of a square pero na equal to summation of y sub I squared no ali yi okay square. Now unsa ang mga ano na ni ang ano na ni is kani AO and A1. Okay, kaya mo man na ang mag-represent sa line. Kung naa ka ana makuha na nimo ang equation sa line. Okay, so unsa na pagkuha ang value sa AO og A1 buhaton nimo na is mo ning A differentiate no differentiate the error with respect to AO. No? Buhaton na to na. Mahimo ning summation of 2 times yi with respect to kuan man so minus constant man sa minus a1 I. Okay, ano na sulat sa nato ni minus AO minus A1 xi dayon derivative aning sulod. Derivative ana niya is kani constant. Okay. Derivative of AO is 1 raman na siya. Okay? Diba? Derivative of differentiate nimo ang x with respect to the x 1 ra na. So the same way 1 ra na siya times 1. Okay? Or wala. And then na po nimo with respect to A1. Okay? So, summation of magapon minus AO minus xi. Pero karon respect to A1 man. So, nakay mag-times ka og xi. Times xi kani. Constant. And then, equate to 0 din para makuha ang list. No? So, mahimo ni sang kani equate nimo na to 0 kani. Equate to 0. So, may tabo karon ana kay duha ka equation. Sa imong equation. 0 is equal to kaning first equation. Summation of actually kaning to constant na pwede na nimo pagawas dire. Nya kay divide na nimo to so mawala na ni. Divide nimo ni to. Mahimo na dayon ni cancel. imong summation of yi. Ha? Summation of yi minus summation of ao minus summation of a1 xi. Okay. First equation. And then second equation is kani. Again, pagawas na to, wala ra pa na to. 0 is equal to summation of xi yi kay naman kay x times that. Okay? Summation of xi yi minus summation of ao xi. Okay? Minus summation of a1 xi square. Okay? Mo na itong dalawa equation. And then ito na ko ni so ning i-rearrange kaya objective man nato is to get AO and A1. Diri eliminate nato na sila diya. So naa kay equation nga nani summation of AO and then transpose to because plus summation of n ang A1 constant pwede rin pagawas A1 xi okay equal to summation of y sub I okay kani kaduha may mo siyang summation of xi AO kani transpose because plus A1 summation of xi square tama equal to summation of xi by I. Okay. So, mga na siya. So, nakakay dua ka equation, dua ka unknown. And then, buhato ni mo ni is pwede eliminate ni mo ng AO or A1, no? Pwede ni mo gamit ka Cramer's rule para makuha ni mo ang value sa AO o A1 or elimination, no? Okay, so we will use Cramer's rule in order to determine AO and A1. Okay? So, but before that we do that, ito sa ni-arrange ng equation. Now, kani siyang efficient or pasabot ana niya, no? Summation of AO from 1 to n. Meaning ana is sample. Muna ito ng summation of 5. from 1 to 3. So, sa may pasabutan na. 5 plus 5 plus 5, no? Taman katulo. So, ang pasabutan na, or this is equal to, may 15, or 3 times 5, or kani, mahimo po ni nga n times o. Huh? Mahimo din yung n times a. N times a. And then kani, variable a1, so ito ning moon kani ang efficient niya, no? Variable a1 equal to summation of yi. By the way, para dali ta, ito na lang ning kung ano, no? Ang galo na sila. Pero, pasabot na ng summation is from 1 to n. Para lang madali ta. Ani, summation of xi ao plus summation of xi square a1 equal to summation of xi yi. Okay? And then, imo na to siya nga matrix form. Imo ning n summation of xi square o a1 equal to yi. Okay. Mao na to ni nga this is mao na ni ang matrix na representation ana. Okay? So sa Cramer's rule, pao nimo ang determinant. Ang determinant kana to nga d is kani. And kani siya unsa ang value ani. So dali ra na siya, no, 4 2 by 2, may mora na siyang cross multiply ra na nimo ana. And summation of xi square minus kani summation of xi times xi. So may mong summation of xi na lahi ng summation of xi square of is not equal to summation of na sila pareha. Pareha. Sabot ani gimultiply mo itself kani. Pasabot ani gi-square nimo ang x then imong gisum. Okay, so may value ang determinant. And then to get AO, para makuha nimo ang AO, kani siya nga coefficient imong puli di ani. So may mo na ang di ani man kay diri man ang AO. So puli na nimo mahimo ning summation of yi xi yi summation of kani sulat na ana over determinant nga d which is kani over n summation of xi squared minus summation of xi squared kana. Therefore, cross multiply ni mahimo ning summation of I square times summation of yi minus summation of xi times summation of xi yi over n summation of xi squared minus. Okay. Mo ni karon imong AO. Okay. So na ni. Mo na ang AO. And then, ang A1, A1 equal to, kanina po, ipuli dire sa may mong n summation of xi, summation of yi, over determinant nga n minus, okay. So, answer ani is n summation of xi yi minus summation of xi dot summation of yi over n summation of squared minus a1. Okay. Muna na siya. Therefore, kuha na rin mo ang imong equation na y is equal to a o plus a1x. No? Plug in na ni mo dire kani mga balian ni dire. Kuha na rin to nimong line na mag-represent sa imong data. Okay? And also this is for linear, no? Linear man isa. Linear regression. So we'll also proceed to polynomial regression. Pero ang process is same ra gid gyapon. Have an example and how to do the linear regression or the least squares regression. Okay, so table 17.1, you have these data points. Okay, you have 7 data points. This one x presented by xi and y sub I. Okay, now the best thing to do is first to graph these points and see whether you can do a linear regression, no? So we will not do that, but instead we'll proceed on how to do the linear regression. Okay, so let's recall a1 is determined by these parameters. Okay, so ang buhaton nato is we'll add xi, we will also get the sum of yi, we will also get the summation of xi y sub I. Okay, or in other words, we will actually get all these parameters na needed. Okay, get summation of xi yi, summation of xi, summation of y sub I, get the sum of the squares of x and summation of x sub I. Okay, after that one, no, we will not actually demonstrate that one because it is straightforward. So based on this data, we'll get that summation of the squares of x is 140, summation of xi yi is 119.5, summation of x is 28, and then this is the mean of x, the mean of y is also 3.4, T2 8571. And then substitute this one into this equation, we will get a sub 1 is 0.8392857. Okay, and then also I have presented another value for AO, and also this is also another way of getting a sub O. So you get the mean of y and also the mean of x. So with that, you have now get a sub O, which is 0.0714287, and then you just plug in these values into the equation y is equal to AO plus A1x. Okay, and then you'll get this one. This is AO 0.0714287 plus 0.8392857x. So this is your best fit for this data. Okay. Now, we will try to answer whether the line that is given by the least square regression is actually the best fit for the data. So in order to do that, we'll need a parameter which will be called the correlation coefficient. Okay, correlation coefficient. So what is that? First, let's get the sum of the residuals, or the summation of the error squared, which is represented by this equation. Okay? So, kanina na siya, 2.9911. Okay, that is the summation of the residuals. And then, what you will do is, to get the coefficient of the determination, this r squared, st minus sr over st. Now, if you recall, okay, so s sub t actually is this one, the sum of the squares of residuals. Okay, so magamit na nimo siya if you get the standard deviation. So going back, the sum of the square of residuals minus the error, okay, summation of the error divided by st. So that makuha nimo ang coefficient of determination. And then if you actually get the square root of that, you will get the correlation coefficient. Okay? So for a perfect fit, no, kung i-fit jud tanan nga data points nimo diha sa line, you will get correlation coefficient of 1. This one. Okay? So pasabotan na niya, the line represents 100% of the variability of the data. And also, you have an alternative formulation, which is this one, R. Okay, actually, gikan na po na sa dire. So, but, take note nga, if does not mean nga ang imo ang R is close to 1, does not mean nga the fit is good. No, actually, kinanglan, although, muna sa atong primary, basehan po nato na siya, pero you need also to inspect the plot of data kung pwede ba siya linear, no? So kinahanglan pud nimo i-plot gihapon ang data. Pero kung ang R nimo tagaan ka og close to 1, very okay jud na siya nga representation. Kinahanglan lang gyud nimo i-check. Okay? So for the program for linear regression, this is makita nimo sa figure 17.6. Okay? So actually, kung ano nimo ang mga sum, actually muna katong sa formula na to dire. Kani ang mga equation.